Good morning, class.
Morning, Jossy.
All right, today we are going to be looking at some examples on projectile, okay?
Yes.
All right, so we have actually done projectile, but I still want to go back and rephrase what is projectile and give you an example, or rather a question to solve on projectile. Is that okay?
Yes.
All right, so today is fifth, right?
Yes, ma'am.
All right, can I get a meter rule? Please, can you see me clearly?
Yes.
All right, let me face the. I can see the board. All right. I don't know if you can see me clearly. So sorry, I'm trying to adjust it. All right. All right. The lines are not equal. Okay, let me just draw another one. Please, can I get a meter rule?
Yes, ma'am.
Give me a meter rule. Okay. All right, as Osapo Okechukwu, can you see the two lines? Is it okay now?
Yes.
Can you see the two lines, please?
Yes, ma'am.
Please, can you see the two lines? The last one is not seen. Is it seen now? Okay, so we can proceed. Now I think we actually want to look into some examples or questions on projectile, right? So let me still go back to projectile. Projectile. You see that a projectile is an object. You already have it in your notes. I just want to rephrase. Then go to vertical and horizontal projection, okay? It's an object that is thrown or launched into space and is allowed to move freely on its own under the influence of what? Gravity. And if we talk about projectile, we have so many examples of projectile in sports and in what? In warfare. Do we have those examples? Examples of projectile in sports are
Shot put,
okay,
thrown discus,
okay,
kicked football,
okay,
and athletes doing the high
and
jump.
athletes doing what?
The high jump.
Okay, they are all examples of projectile in sports and in what? Is that in sports alone?
Yes.
Okay, so what of examples of projectile in warfare?
A stone released from a catapult,
Okay,
a fire spread,
okay.
a shot arrow.
Now, all these examples, they must make this motion. Motion of the projectile is what? Is this right?
Yes.
The path of a projectile is called what? A trajectory or
A
a
parabola.
parabola, right?
Yes.
A parabola. This is what we call parabola. If an object move and get to this highest point, this is the maximum what? Height, right?
Yes.
This is the maximum height, and once you get to this point, you're going to return to the what? To the ground, right?
Yes.
Okay, there is a time required for you to get to this highest point. We call it small t. Okay? And this projectile move with an angle called what? Theta. Now, if it takes this object 2 seconds to get to this highest height, or to this maximum height, it's going to take another what? 2 seconds to do what? To return to the ground. So if I ask to calculate the total time taken by this object, it says what? 2 plus what? That becomes the time of what? Flight. The time of what?
Flight.
You know, the things I told you that you have to know, the first one is what? Small
Time.
t, right?
Yes.
The second one is what?
Time
Time of what? Flight. And the third one is what?
The maximum height.
And the last one is what?
Range.
Do you understand?
Yes.
So these are the 4 concepts you have to experience under what? This projectile. Is that okay?
Yes.
So what I'm going to teach you today is horizontal. Okay, let me start with vertical projection. Vertical what?
Projection.
So write it. The topic today is what?
Vertical projection.
Vertical projection. Still under projection, so it's not a new topic. Okay. So you should write when an object is projected vertically. When an object is projected what? Vertically. It means that the angle of projection is equal to 90 what? 90 degrees. 90 degrees. When an object is projected vertically, it means that the angle of projection is what? 90 degrees. That means theta is equal to what?
90.
Theta is equal to what?
90 degrees.
Now let me explain what I mean by that. This is an object.
Excuse me, ma'am.
Not now. I'm having a class. After the class, just a period. Come back. All right. So I see the diagram on the board.
Yes.
Okay. So this is the horizontal ground, right?
Yes.
Now I don't know if this my line is true. Let me draw it. If you throw an object up, the object will go with a time this way, right? And returns back. The object is not going this way, the normal projectile or the normal projection. This is just basically throwing this marker up like this. It will go up and do what? Come down, right? So we are considering so many things. What are we considering? One is what? The time to reach where? The maximum height, right? And two is what? The total time. That is the time of what? Flight. Because once the object gets to the highest point, it's going to also what? Return to the what? Ground. Then the time you're going to look is what?
Range.
The maximum height. No. Range is a horizontal projection, so we are not considering range here. So remember that we threw this object up. So we are considering from here to here, made an angle of what? 90 what? Degrees. So here theta is what? 90 degrees. Is that okay?
Yes.
Alright, so put it down. Let us derive our formulas for time of flight, and the maximum height. Thank you for coming. Please give it a thumbs up. Are we done? Now, can we proceed?
Yes.
All right, so let's proceed with what we have on the board. All right. Stop making that noise. Now, under horizontal projection, under vertical projection, I say I'm considering how many things? 3, right? The first one is what? The time to reach the maximum height. That is that small letter T, right? Then the second one is what? The time of and third one is what?
Range.
The maximum height. Range, this is what? Horizontal. I don't believe it's what? Horizontal projection. So you are considering vertical now. When we are done, we're going to go into what? Horizontal. So the first thing is my T. Remember that the formula for the time to reach the maximum height is U sine theta over G, right?
Yes.
If it is U sine theta over G, but my theta, which is the angle of projection, is 90 degrees. Okay? So, okay then. What is sine 90? Let's say T is equals to U sine 90 over what? G. Then sine 90 is equals to what? 1. That means my T is equals to U over what? G. Do you understand?
Yes.
If they ask a question that an object is projected vertically, you should find the time to reach the maximum height. You're just going to say T is equals to what? U over what? G. You know what U stand for? U stand for what? Initial velocity. And G stand for what? Acceleration due to gravity. Okay? Then the second one, which is the time of flight, is equals to what?
C equals to
2U sine theta over G.
Okay, so that means our capital T, which is time of flight, is equals to 2U sine theta over what?
G.
But we still remember that our theta is what? 90. And sine 90 is equals to 1. So for me to get the time of flight, I'm going to say 2U over what? G. Do you understand?
Yes.
So this is the formula for the time of what? Flight. Do you understand?
Yes.
So put it down, let's proceed. Peace, Ostapwe, thank you for coming. Rhea and Was, thank you for coming. Please give it a thumbs up. Are we done?
No.
Okay. So the next thing we are going to look at is what? What's remaining?
Maximum
height.
The maximum height, right?
Yes.
Okay, so let's look at the maximum height. Then that's the third one. The maximum height is equals to h, right?
Yes.
H max then is equals to
U square sine
sine what?
sine theta
Over what?
2G.
Okay, u square sine square theta over 2g. I already told you what is sine square theta. Just like saying sine theta all what? Squared. Okay? And we already know that theta is what? 90 degrees. It's just like saying 1 squared is equal to what? 1. Do you understand? Sine square theta means sine theta all what? Squared. Right? So the formula of maximum height becomes u square over what?
2G.
U square over what?
2G.
And this will take place only when the object is projected what? Vertically. And the question must specify that it's vertical projection. So you know when I give you normal projection, you're going to use this one, you're going to fill it. Okay? So if an object is projected vertically, you're supposed to use this. I've given you how many formulas? I've given you for t. T is equals to what? U over what?
G.
I've given you time of flight, which is what? 2u over g. So these three formulas will go into what? To go into what? Vertical projection. Go into what? Vertical projection. And under vertical projection, you don't need to look for what? Range. Okay? Alright, copy fast. Let's solve one example on that. Alright. Are we done?
Yes.
Okay, let's solve an example. We don't have good dust. How much can that get dust for you? Fast. Question. An object is projected vertically. With an initial velocity of, let me say, 50 meters per second. Okay? Calculate I is what? The time, right? The next one will be what? The time of flight. And the next will be what?
Maximum height.
The maximum height. Alright. Copy down the question. Let's see if you can attempt it. Are we done writing?
Yes.
Okay. Know that G is constant. You know that
Yes.
G is equal to what? 10 meters per second what? 10 meters per second square. When you are solving, don't put the unit inside until when you are done. Okay, you don't put unit inside what you are doing until when you are done. Are you not writing the question? Carry on, listen to the graph.
Going to your answer carry
Which one?
for the time.
Time is measured in seconds now. Time is measured in seconds. Are we solving?
Yes.
Just apply the formula, you're going to get the correct answer. First, what's the formula for time?
U over G. U over G.
Just are we using that time? Where is it? Why are you going back and front? This is the vertical projection. What's the time I gave you for small things? It's not you over G. Are you done?
Yes.
You which one?
The three.
So what's your
First answer.
first answer?
Like
5 seconds. Units. Seconds. What's the second answer?
10 seconds.
10 seconds.
Yeah.
So what's the maximum height?
125.
200 and what?
125.
25 watts. 25 watts. Height is measured in watts. Eh? Eh? How did you get it? It tells you measurement in SS1. Height is measured in watts. Meters. Anything that is short distance is measured in meters. Okay? Whether it is length, we are not sure. Whether it is length, whether it is breadth, it's measured in what? In meters. Okay? Alright. So, 16 all done. I've told you when you are solving, don't put your units inside your work. Don't put your units as you are solving. So you are done solving, you cannot put your units, okay? Alright.
So U.
What is U?
U is 50.
Put it down as you can get your answer. So, who will solve the first one for us? Who first come and solve the first one? Take the calculator, you can just see them that way. You have not finished solving, finish your work first. Have you done the maximum height? So find the maximum height. Take. That's one.
T equals to initial velocity all over gravity.
Okay.
So we said T is equals to our initial velocity
It's
is
solving inside here so they can see you.
our initial velocity is 50. So you write 50 over gravity is constant, so it's always 10. You write 10. Then do 50 divided by 10. And 50 divided by 10 is 5. Answer is 5 seconds.
Okay. You do not itemize it. You can go, you have tried. Is it correct?
Yes.
Please give me a high five. Give me a clap. So what's the first, second one is what? Eh?
Kind of fine.
What is all?
Yes.
You saw me tell me.
My
Okay.
city face.
Don't worry, I have another question for you. Don't worry. That's okay. Hi, you're welcome to our class today. This is SS2 class. Okay, it's class 12. Thank you, Nafizi Onyeka, you're welcome. What's the answer?
10 seconds.
Is it correct?
Yes.
Okay, give me a clap. So can I solve the last one? So I'll go to another. Solve it one down. Yes.
Okay, so I'm looking for maximum height and maximum height is equal to u squared over 2g. Our initial velocity is 50. So it'll be 50 squared over 2 times our gravity, which is constant, and that is 10. So 50 times 50 is going to give us 2,500 over 2 times 10 is 20. So if 0 comes to 0, 2 here, 2 into 250 is equals to 125 meters.
Write it on the.
Yes.
Like clap. So now we are done with the. These are the questions you can see under vertical projection. Okay. So let me go into horizontal projection before your period elapses. Okay. You end by 11, right? Okay. So let me go into vertical projection, or should we solve more problem on this?
Horizontal.
Horizontal is going to take a long while. There's a question I
Let's
saw.
continue.
There's a question I saw here. Okay, now solve this question. An object is projected vertically. Are we together? Yes. An object is projected vertically. It's projected vertically. An angle of 60 degrees to the horizontal. It's an angle of 60 degrees to the horizontal. And initial velocity of 20 meters per second. Initial velocity of what?
20 meters per second.
Calculate one. Calculate one. The time to reach the maximum height. 2. The time of flight. And 3. The maximum height. three parameters we have here is initial velocity u is 20 meters per second, the angle is 60 degrees, and g is equals to what? 10 meters per second square. So you have to calculate for three things. One, the time of flight. Two, the time to reach the maximum height, and the what? The maximum height, okay? So are we done with the question? Do you get the question? So, the same method of what you did the previous time. Are we done? Your time is almost up. It's up already. So that's that. Which I think what's your time to reach the maximum height?
1.732.
1.732. Are you sure?
Yeah, 2 seconds.
Is it not u over g?
No, time to reach the maximum height.
That is small t. Is it not small t?
Yeah.
So what did you solve?
The
The normal one.
no.
Yes.
Yes.
Wait, did it use theta over g?
But I said that the angle is the object projects vertically. You should use the vertical projection, not the normal one. So you should not forget. Answer is 2.
2 seconds.
Yeah, it's not supposed to take you that long.
Confused.
But
No angle. The angle is plus 90 degrees. No angle. And I told you that. Okay.
you.
Why did you leave the whole of this space? You're wasting your whole like 60%. You what? Is it not still projectile you are doing? Why is it new topic? So correct yourself so we can go. Are we done?
I'm confused. Wait. We used angle, which was 90. And then we used the first angle of 90 degrees. So this time she gave us a new angle, 60 degrees. You know what's confusing and so pressure? Video delay dancing.
Okay, you can go. Clap music.
Excuse me, mom, collecting noise.
Okay. What?
What is it now? Wait first, wait. Not approaching.
Excuse me, mom, please don't to make your laboratory.
Okay, go.
I don't do that easy.
Are we done?
Yes.
So who will do the first one for us?
Excuse me.
Yeah, take. Now go and solve. Let's stop with your nose. I'm giving you the parameters. So go and solve.
Dancing in front of it. I'm done.
Is it correct?
Yes.
Are we looking for time of flight or small t?
We are looking for something.
You look beautiful.
What is that is big T.
No, oh god, just the first part. You wrote big T, not
Okay.
little.
So the second one, who will solve? Who will solve the second one?
You see, I use 20 over 3 times 20.
Is it correct?
Yes.
Okay, the last one, so I can go for the next class. Who will solve the next one? Okay, be fast, so you go for your chemistry class. Chemistry is- Is she correct?
Yes.
Alright, so we are done for today, okay? When next we meet tomorrow, we're going to do horizontal projection. So go for your chemistry class. And call us a small. Call us as one student for me. Come in, keep quiet. Open the. What's the window? The reflection is too much. No duster. Except one carry the duster. I don't. People can sit at the back. Settle down. All right. Now, where did we stop the last time?
Acceleration.
Acceleration.
Yes.
Yes.
Can I see your notes? You have done position, distance, and displacement.
Yeah.
Acceleration.
Eh?
Yeah, I've done.
Have you done scalars and vectors?
Yes.
Now, do you understand the calculation questions we did?
Yeah.
Are you sure?
Yes, ma'am.
Do you still understand how to convert kilometer per hour to meters per second?
Yes.
All right. Convert. Question. It's still under motion. They are still under motion, not a new topic. Okay. So they are going to be solving problems on motion. Speed, velocity, and acceleration. Okay. Convert 36 kilometers per hour. Convert 36 kilometers per hour to meters per second. Convert 36 kilometers per hour to meters per second. All right. What's your answer?
10
10 meters per second, right?
Yes.
I still solving. Yeah? Right? I still solving. And if you don't read after each class, that's what it means. What are you supposed to do? It's not to say 10 times 1,000, right?
over 60 times 60.
Because 1 kilometer is equal to what? 1 kilometer is equal to 1,000 meters, right?
Yes.
Then,
Unit
how
of
many hours are there in one? How many seconds are there in 1 hour? How many seconds are there in 1 hour? 3,600 seconds. Okay? That's why multiply by 1,000 and divide by what? 60 times 60. All right. So you're going to look at a few examples. Have you done scalars and vectors?
no,
Have you done scalars and vectors?
no.
Okay, that will be the next topic we are going to treat tomorrow. see the equations of motion? Where are you going to?
Motion. Let me check. I haven't.
Have you done see if you don't know scalars and vectors?
Yeah, maybe that's what
Okay. Alright, so let's see where we are. So let's get to work. We are still under speed, velocity, and acceleration, right?
Yes.
Have I given you equations of motion?
No.
Okay, I said that is SS2 work,
Yes.
but I think we don't talk of acceleration.
Yes.
Acceleration is equals to what? V minus U all over what? Okay, so let me give you some questions under that to see if you can be able to solve it. All right. Look at this question. A car accelerates uniformly from rest, okay, at 5 meters per second square. Determine the speed, or determine its speed. Let me change it to its speed. Its speed after 10 seconds. Okay? Now we'll be able to attempt this question.
Yes.
Okay, so copy and solve. You also the answer. You don't know what you are doing. You can't play. So, which formula are you supposed to use? Which formula are you supposed to use? Which formula are you supposed to use?
A is equal to
Equals to
B minus U over C.
That is equals to what?
B minus U over C.
Okay. the next topic remaining for us this term is
Scalar vectors.
is everyone remaining?
Scalar vectors, friction and circle. Okay, we have done motion. Scalar vectors, friction, and work, energy, and power.
Okay. What's your answer? 50.
Yes.
50 meters per second, okay? So one person should come and solve for us. I will come and solve. Because what we are going to do friction. The left hand is not true. This class is ended by
Jossy. No.
is this superior?
After.
Yes. Okay, now since I have a few minutes to go, we can discuss scalars and vectors since it's not much.
Yes.
Discuss scalars and vectors today so that tomorrow go into friction. Friction now leads to circular motion.
Yeah.
Let's know whether I can complete that before your exam. I don't know if you're starting exam this month.
This one. Yes, this one at the end of this one.
Month end, right? So that means we have 2 weeks to go. Alright. Scalars and vectors. That's a new topic. Scalars and vectors. Scalars and vectors. Are we there?
Yeah.
Alright, so we're going to look at the concept of scalars. So let's discuss scalars first. Concept. Concept of scalars. Concept of scalars, okay? Alright, so let's go into scalar quantities. Alright. All right, copy fast. Let's explain. Are you done? Are we done writing?
Yes.
Okay, let me explain. All right, concept of scalars. Now, there are some measurable physical quantities. There are some measurable physical quantities that have only magnitude. Magnitude means size. Like the way this marker is now, I can measure the size. I can weigh the size because it has mass. Okay, so it has mass, I can weigh it. But I can't say much about direction because it does not have a particular direction.
Yeah.
It has mass because it has weight. Do you understand? So we can measure them by their mass, but they don't have what? Direction. So all those quantities are classified as what? Scalars. Classified as what?
Scalars.
Any quantity that have size with no direction seems to be a scalar what? Quantities, right? So we can say that scalar quantities are those quantities which has only what? Magnitude or numerical value, but no what? Direction. They can be added by ordinary algebraic method. Now what is algebraic method? When we add mass, how many mass am I holding? Two, right? I can say 1 plus 1, that is what? 2, right? The same way I can add what? Algebra. By saying x plus x, that is what? 2x. X plus x, that is what? 2x. So that is where we add scalars because they don't have what? Direction. They don't have what? They only have only what? Magnitude with no direction. So examples are, we have length, mass, time, temperature, energy, density, speed, work, pressure. All these are under the examples of what? Scalar what? Scalar what?
Quantity.
Can you give me the example of scalar quantities, Wes?
Length,
Mass, time, temperature, energy, density, speed, work, pressure.
So what are scalar quantities?
Scalar quantities are those quantities which have only magnitude or numerical value but no direction.
Only magnitude and numerical value with no what?
Direction.
Okay, so let's go to concept of vectors. Concept of vectors. noise. We should get a good duster. This one is dirty. I even get a rag. I think it's preferable. Get the rag. This one. No, don't worry. I can manage this. Concept of what?
Better.
Can you see this end?
Yeah.
Are we done writing? explain. Concept of what? Concept of
Vectors.
vectors. Some other measurable physical quantities have both magnitude and numerical size and also what? Direction as well. And those quantities are classified to be what? To be what? Vector quantities, okay? So vector quantities are those quantities that have magnitude as well as what?
Numerical value.
As magnitude or numerical value as well as what?
Direction.
So for a quantity to be classified as a vector quantity, it must have what? Magnitude and what? It must have what?
Magnitude and direction.
Okay, they can be added by geometrical what?
Method.
And added by what?
Geometrical method.
What I mean by geometrical method? You must notify whether it's going east, north, south, and what?
West.
That was why when you calculated displacement, you have to look for the what? Direction, because displacement is a vector what? Quantity. Do you understand? Okay. Examples are displacement, velocity, acceleration, force, moment, momentum, weight, electric what? Field. Do you understand? All these ones are classified under what? Vector quantities because they have both magnitude and what?
Direction.
Both magnitude and what?
Direction.
Alright. We have question. We have question. Electric field is a region where an electric force is experienced, or where a charged body experiences an electric force. Okay, I think that is second term. That is second term work. We're going to do that. That is second term work. So can someone tell me what is distance? Question time. Question time. What is distance?
Distance is
The
the
gap
surface
or
of a from
between
point
two
to
objects.
another.
What is distance?
Distance is defined as the gap or separation
Between two objects.
Distance is defined as what?
the gap or separation between two points.
Okay, I'm not looking through your notes.
No.
Okay, let's see how it goes. All right. What is position?
Position is the position is defined
Defined
as position as defined as the point
object.
where an object is located.
If you know the answer, you raise your hand and answer me. What is position?
Position is the exact place or point an object is located.
An object is found or what? Located. Okay. And we said that objects can be found on a plane or in space, right?
Yes.
Plane is characterized by how many coordinates?
Two.
Which are what?
X and Y.
Y space is characterized by how many coordinates?
Three.
Which are what?
X, Y, and Z.
So what is displacement?
Displacement is defined as the distance covered in a specific direction.
Are you reading from your notes?
No.
What is motion?
Motion is defined as
The
the
change
movement,
of position.
a change of position or movement.
I said if you know the answer, you raise your hand. Let me know people that knows the answer. What is motion?
Motion is defined as a change of position of an object.
Okay, so we have how many types of motion?
Four times.
Name them.
We have random motion, oscillatory motion, rotary motion.
Do you have rotating motion?
Yes.
Rotational, oscillatory, random, and linear motion.
Now, a woman in a crowded market is said to undergo what?
Random motion.
Why is it random?
Because
Walking in different directions.
that's a specific direction.
A merry-go-round is an example of what?
A rotational motion.
Because it moves what?
Circular motion.
The beating of the heart is a type of which type of motion?
Oscillatory motion.
Because
It is an fixed axis.
It's a motion that happens in a fixed
And in a fixed point.
no.
It moves to and fro.
to and what? Fro. And it repeats itself at regular interval of time. Okay? A bus moving from point A to point B is said to undergo what?
Linear motion.
Because
Yeah,
straight path, right?
Yeah.
I'm going back to what we have done previously, since we still have 3 minutes to go. What are fundamental quantities?
Fundamental quantities are quantities that are independent of other quantities.
Now, who will tell me the 3 main fundamental quantities? Yes?
Length, mass, and time.
Now, who will tell me why they are important? Yes?
They are used for the derivation of other quantities.
No?
They are the basic quantities.
No? It's in your notes. Why are they important?
Yes, determine the dimension of other physical quantities.
Because they determine, you've seen it in your notes, have you?
Yeah.
Because we then determine the dimension of other words.
Quantities.
So, no, not just that, not just that. What are derived quantities?
Derived quantities are those quantities that depend on fundamental quantities.
Fundamental quantities, right?
Yes.
Examples are
Area, volume, speed, displacement, acceleration, moment, force, and
So can someone tell me the unit of force and the dimension of force? Unit and dimension, because once you get the unit, you can get the dimension.
Okay, yeah. So the unit of force is kilometer meter per meter square kilometer kilogram meter per second square.
You don't need to. I think you don't need to memorize all this.
Wait, is it kilometer meter per second square?
You don't need to.
Why do you not?
You don't need to memorize.
How to put the
Mass,
You don't need to memorize. Okay, so you need to know what this is all about. Okay, know how we generate the unit of force. Knowing that force is mass times acceleration, right? You now know the unit of mass and unit of acceleration. Bring them together. That is unit of force. You don't need to memorize.
Like I want to pronounce it.
Kilogram meters per second square. You have learned it by now. So what's the unit of density?
Unit of density
Kilogram
is
per meter cube. That's how it's just
Kilogram what?
per meter
Per meter.
cube.
So what's the dimension?
The dimension is ml minus 3.
ml power minus what?
3.
What's the unit of force?
Unit of force is mass times acceleration.
What's the unit of work?
Kilometer of force. This is derivation.
Kilogram per meter square.
Kilogram meter square per second square.
Oh,
Yeah.
like I was close.
Yeah.
Kilogram meter square per second square. So you have to get C. I've told you several. You don't need to memorize. You don't need to cram. So what I'm going to do is to know the definition. If work is force times distance, okay, you're just going to say what?
If force.
You already know what is force.
Yeah.
If work is force times, you already know what is force, unit of force.
Yeah.
Multiply by distance. Even if you don't know the units of force, you already know that force is mass times acceleration. I know the units of mass, know the units of acceleration. Bring them together and get the unit of work. Okay.
Yeah.
What's the reading accuracy of a vernier caliper?
0.01 centimeter.
What's the reading accuracy of a meter square wave?
0.001 centimeters
Or
0.01 millimeters.
Yes.
what's the reading accuracy of a beam balance?
No.
Do you know the measurement of mass?
We need balance.
Okay. You don't know what beam balance is.
Did I give you measurement of mass?
Measurement of mass.
You don't know that spring balance is from weight.
Wait. Yeah.
Okay. But you can generate the difference between mass and weight.
Yes.
Mass is measured in what?
Mass.
You measured in kilogram. One weight is measured in what? One weight is measured in what?
Newton.
All right. We are going to look at friction. That will be tomorrow, okay? So for now, we still have time. So let's solve problem. Not more than 10 minutes.
We don't have break.
You don't have the
Yeah.
how?
Teacher's class.
Break. You have taught you people today.
No.
When is he going to teach you?
During break.
That's after my class.
No.
So let me allow you to go and come. And then take your break. Okay?
Thank you.
All right. See you next time. Hello, thank you so much for sticking to the end of this class. So we are done for today. Okay, thank you for coming. I'll see you next time in the next one. Bye.